All right, so how do we graph sine and cosine functions with transformations? So we have our little formula, and so what do all of those mean? So our A is our amplitude, meaning how high. I think of it as how loud it gets. B changes the number of cycles we have in 2 pi. So instead of having a little pi symbol, which I couldn't get on here, we have that. Phase shift, meaning it's left to right from where it started normally. So again, remember they start, if we think about the unit circle, they start at 0. And where they start, we should say sine at 0 is 0. Cosine at 0 is 1. That's why when we're graphing them, cosine starts up and goes down. So that's our cosine. Where sine starts at 0 and then goes up. So cosine up goes down, sine starts at 0, goes up. Okay. Vertical shift, I call it the midline, but that's basically here that we would move up. So from that midline, then we can figure out what our amplitude is from there. Okay, so we'll do these 4 on these like 2 little graphs in different colors. I know, it's so cute. All right, so just regular cosine of x. We know that the period is 2 pi. Normally on all of these will be 2 pi. So that means it goes through the whole graph in the space of 2 pi. So I call these landmarks. So it's basically where the unit circle is at 90, 180, 270, and 360. So we have pi over 2, which is our 90, pi, which is our 180. And so it's half a pi, 1 pi, 1.5 pi, so 3 pi over 2. And then our 2 pi, right, our 360. And if it's cosine, we'll just make a really big amplitude at 1 and -1. So it oscillates, meaning it goes back and forth in between 1 and -1. And if you could see me, you would have laughed because I did the up and down thing with my finger like you could see me. Oh, I'm such a dork. Okay, so cosine x starts at 1. It's going to go up, middle, down, middle, and then up. And that's 1 full cycle of cosine. Voila. All right. Then we start making changes on it. So in this blue, we have y equals 2 cosine x plus 3. So what I would do if I were you, I would remind myself that the amplitude is 2, that I'm moving it up. So I move the midline up 3. So this was our midline. So what that thing did for the regular cosine x, we're going to visualize it moving everything up. Okay, so for the blue, we're going to start. Okay, now it was a dorky thing to put 1 here, but we'll just go 1, 2, 3. Okay, it has an amplitude of 2, which means it's going to go down to here. So that's our 1 now, and then it's going to go up to 5. Okay, so again, what I like to do is go remind myself, okay, here's my midline. If it'll draw, there it goes. There's my midline. And I don't have any phase shift left to right. I don't have any changes in the period. It's still 2 pi. Remember, that's what that B does, is it changes how smooshed it is in or how wide it gets. So again, I have my landmark here, 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 and here. So I call them 4 landmarks. And you'll know if you take the period and divide it by 4, so here 2 pi divided by 4 is pi over 2. That's how much each step from one landmark to the next is. Yeah. All right. Cosine starts up, so it's going to start up at 5. Because remember, our amplitude was 2. So it's going to go up, middle, down to our blue one, middle, and then up. And there's our cosine. Awesome. I know. Okay. To the red. So this one, we have the midline is down 2, but now we have this B. So what we do with that is we say, well, the period is 2 pi divided by B. All right, so we're going to take that 2 pi divided by 4. So our period is pi over 2. Okay, that means we have to get this whole graph smooshed together to fit into pi over 2. All right, so I'm going to try to keep my landmarks the same so we can see the difference in them. So pi over 2, so half a pi, full pi, 1.5 pi, and then 2 pi. So again, our graph has to fit, that's a beautiful 2, has to fit in the space of pi over 2. All right, so again, if I want to know what each of those steps is, I'm going to take my pi over 2, right, pi over 2, and divide it by 4, which is the same as multiplying by 1/4, right? So that's pi over 8. So each one of these steps, I always say chop it in half, half, and half. That's pi over 8. This is 2 pi over 8, which we reduced to pi over 4. So 1 pi over 8, 2 pi over 8, 3 pi over 8, and then 4 pi over 8 would give us our pi over 2. See, not too bad. It's been moved down 2. Oh, forgot to do that one. So down 2. There's our midline. Okay. We have an amplitude of 1. So we just are going to go down. So that goes from -1 to -3. Cosine starts up. So it starts not at the midline, but up. Then middle. Then down. Then middle. And then up. So we have our full cosine all smooshed. Where it was spread out over 2 pi, we now have it at pi over 2. So what this 4 is telling us is that I could now get 4 full graphs in the space of 2 pi. So it gives me 4 times as many. It would have been but 1, 2, 3, 4. Make sense? Hope so. Because I can't see if you're nodding or anything. Oops, there. Okay. So the last one is kind of a full meal deal. So we have an amplitude of 3. We have a b of 2. So our period is 2 pi over 2, which just gives me pi. Okay. I divide that in 4, so really pi over 4 will call us each step of our landmarks. All right, but we have pi over 2, x minus pi over 2. So that means it's starting to the right at pi over 2. So we take the whole graph, instead of starting at 0, we're just going to shift everything down to start at pi over 2. We also have a midline shift up 1. All right, so let's get our landmarks down first. So I'm going to take our midline goes up to 1 because we're shifting everything up 1. Beautiful. All right, so that's done. We have an amplitude of 3, so I have to go up 1, 2, 3. I go down. That was a shift up 1, so that would be 1, 2, 3, somewhere in here. Okay, that's done. Oh, Lucy had to say hi. She loves graphing trig functions. Okay, we start right pi over 2. So our starting point now is right here. Right? And our period then is pi. So we're going to go a distance of pi, not at pi, but one more over. Everything has to fit within there now. Okay, so here's the middle, and the middle of that one, and middle of that one. Those are our landmarks. So pi over 2 in each step is 1/4 pi. So this then would be 3 pi. Wait, am I right here? I don't know. Hold on. Okay, so we'll just go from there. Oh, so distracted. Okay. What else do I have? Oh, my amplitude is 3. So cosine, I'm going to start up. So it's going to go up, middle, down, middle, and up. And there you go. So everything works the same, sine or cosine. except that we know that sine, everything would have started at the midline and gone up. Okay. What we didn't talk about is if it's a negative out in front of the amplitude. And what that would do is instead of starting up, it would start down. So just like our parabolas, positive parabolas were here, negative parabolas were just flipped over. So everything here would switch places. Okay. So remember, the math never changes. The numbers just get uglier. So how we would transform x squared, x cubed, these all move the same way. So that makes it easier. The bummer is there's just a lot of them to remember. Okay, but the good news again is that they all move the same way. Okay, so we're going to see if this works, and then I'm going to start doing some problems from the review that we have on graphing those trig functions. All right.